Here's a short video on how to use the perfect square method to solve or simplify radical expressions. So we have a three-step process, and step one is for us to find the largest perfect square that the radicand can be divided by. So I'm going to go ahead and do that. I'm going to number this as my number one question because I'm trying to simplify the square root of 20. Okay, and up above you see I've already created your perfect square list, so you're able to write that down on your sheet of paper. And since we're trying to find the largest, that means I want to go backwards, and I'm going to stop when I get to that first number that is smaller than the radicand. Okay, so that's 9. So then I'm going to try to divide my radicand by this number, 9. 12 divided by 9, and I'm checking to see if I get a whole number. If I get a whole number, then that number can be used to rewrite my radical. If I do not get a whole number, then I have to move on to the next one. So 12 divided by 9, if you type it into the calculator, you get a decimal. So that means I cannot use the perfect square 9 to rewrite 12. So I'm going to move on to 4. 12 divided by 4, you get 3. You get a whole number. So that means that is my largest. That would be my largest perfect square. So I'm going to box in 4 as a reminder that it's my perfect square. 20 divided by 4, I get 5. And so my next step tells me that I need to take the square root of the perfect square and put it on the outside of the radical. So now that I know a perfect square, I can find the square root of it easily by asking myself what number times itself gives you 4. Well, the answer is 2. So 2 will go on the outside of the radical. And my step number 3 tells me to leave the imperfect square under the radical. 5 is imperfect, so that number will go underneath the radical. So for my answer, I would type in 2 square root 5. So in my box here, I'm going to press 2, press my square root button, and then put 5, and then I'm going to enter. Okay, I'm going to skip down to some more challenging questions. So that is an example of one where you don't have a number on the outside, but there will be eventually some that show you a problem that has a number on the outside in front of the radical. So let's see if I can get one to come up on the screen. Here we go. Ooh, and they give us a large number there, 363. And I may have to go a little bit further, I wonder, with my square root list. But let's just go ahead and try it. So that you can see, it doesn't matter how big your number is, you're still going to do the same thing. So this one is different, yes, because the number underneath is big, but there's even more, another reason why it's different, because you have a number in front of the radical. So there will be some that comes up that gives you a number that is in front of the radical. So I'm gonna find some more. So we have our perfect square. I can add on to this and say we have 169. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared would be 256. 17 squared would be 289. 18 squared would be 324. And then 19 squared would be 361. And then I bet after this one, of course, we're going to get to a number that's greater than that. So we don't need to go any further. Now you'll notice a pattern. I'm just telling you to start with the largest number that you get to. So that would actually be 361. So I'm going to take 363 divided by 361, and I know that's not going to work because those numbers are so close to each other. So it'll be impossible to take it and divide it into 361 groups. So I'm going to continue down my list until I find one that works. And the one that actually works is the 121. So the perfect square that I would have to use is 121. The largest perfect square that I can use is 121. So I'm going to box it in because that's my perfect square. When I take 363 divided by 121, I get 3 as my imperfect square. And so the second step says, now that you know the perfect square, take the square root of it. What number times itself gives you 121? Well, that answer is 11. And then the third step says to leave the imperfect one underneath. But on these problems, when you already had a number that was outside of the radical, we can't forget about it. So now that both of these are outside together, they can come together and play with each other. So we have 33. So we're multiplying them. And then this 3 is still in the house. So it doesn't get to come out. So we have 33. So my answer is 33. And then I'll press my square root button and I press 3. Enter. Okay, so those are the two types of problems that you'll see on this IXL. Whether the numbers are big or small, you still do it the same way by following these 3 steps.